It sounds like an A, but yeah, you got it.
Okay. Hello.
Nice.
Testing. Yeah.
Woo!
CJUG tonight. Yeah, we try to start on time. So because Daniel will have a full presentation and could go over an hour to like an hour and a half. So we want to make sure we start early.
3 hours.
Yeah. Well, you're in.
I want to go home. That's right.
Anyway, but it should be great. We're so happy to have Daniel here today. So yeah, so is it all good? Jay? Yeah, we'll make sure our video, we're on live stream. Okay, cool. So first of all, welcome again. And tonight we're actually also partnering with, besides Chicago Java Users Group, we also have Chicago Kotlin Users Group. And John Burns, he's the leader of the CKUG. He actually got a bit delayed at work at Grubhub, and he's on his way too. But otherwise too, yeah, we've been like collaborating a lot to do events. So tonight is one of those nights, and plus we have special also group to be with us, which is the virtual Java users group, and I'll show you in a second. So tonight we'll have Daniel Hinojosa. Let me make sure I say it correctly.
There we go. Yeah.
Hinojosa. Talking about Java design patterns revisited through a functional lens. So let me go ahead with just some housekeeping, but first I wanted to welcome again the VJA, Virtual Java Users Group, and they are a virtual presence, but they actually, the folks who run the group, they are based in London too, if you're familiar with them. And maybe you're already a member of them as well. They are really cool, having speakers from all over the world too. So we have a warm welcome tonight to our Java friends from around the world. So if you're on virtual Java, welcome. This is the first time we're trying it out with CJUG, and Sam, I wanted to thank you, especially Sam over there, and Kim too, but Sam is the one who's staying up late tonight because, as you know, in London, it's like past midnight now, and she said, oh, no problem, I can turn the switch on, but I think later she's gonna give us the key, so she doesn't need to stay up, but for the first time, she said she wants to stay up, so thank you, Sam. So tonight, if anybody is here, if you're watching too, if you have problems, we also therefore have the simulcast to the virtual jug link too. So if you kind of take a look at this, and I'll be sharing on our YouTube channel the link to this slide deck. So if you miss it, you can get access to the YouTube link on Virtual Jug, or if you go to Virtual Jug YouTube channel, you'll find the link as well. Okay, before we start, just want to give you the goodies, which is today's raffles. Normally, we have 2 JetBrains licenses that we're raffling off at the end, right after the presentation, after the Q&A. And tonight we have one special one, and that's why there's also the one purpose of tonight's talk is also to introduce to you or kind of remind you there will be the resuming, I guess, of the No Fluff Just Stuff Great Lakes Software Symposium. So it's a mouthful, and if you're familiar with the No Fluff series, they are really great. They have speakers, for example, like Daniel, Fancat, and Josh, and I think a bunch of really great speakers too. And this year I'm very fortunate to be invited to speak there for the first time. So that will be on May 16th and 17th. So if you want to check out No Fluff Just Stuff, and Jay, who is the owner of this conference series, he has donated 1 free admission ticket and to be raffling off at today's meetup too. So please stay, towards the end if you're interested in participating in that raffle. But I do have to say though, for folks who are not in Chicago, then you won't be eligible for entering unless you know you'll be in Chicago. We only offer to folks who will be in Chicago and can attend that conference too.
Wonderful.
So, yeah, and then this is how you enter if you haven't already done so, the QR code, also the bit.ly link if you're interested in entering. Essentially 3 things to be raffling off. Okay, so now the housekeeping. Just remember, too, we have the Chicago Tech Slack. If you haven't already joined that, it's a Chicago area that kind of invited everybody to, not just Chicago folks, but you can join that Slack channel. And then also the Java Offkeep run by Freddie Gemay and also Bob, who's still helping us at times too with the CJUG too. It's very popular podcast if you're not aware of it yet. And then we are also on meetup.com if you haven't already signed up with us. And we are also on X, actually Twitter, the old Twitter, and that's our handle there. Actually, I need to also update. We also have Mastodon too, and I'll update you next time. I always forget about that. Okay, and then we are now also on Discord. If you haven't already, join us there and would like to join us, and that's our Discord link. And also for tonight too, we create, every time when we have a meetup, we would create a special room, so then it can facilitate your conversation with the speaker too. So if you have questions and things related to the meetup, you can always find a room that's created for the meetup. So tonight's room is the one here listed below. By date and by title of this talk, of this presentation too. And then community info, wanting to remind you, if you plan to go to Europe, to Germany in May, JCon, which is a very popular Java developer conference and now expanding to many different topic areas too, they will be celebrating the 10th anniversary of JCon, and also Java is 30 years old this year. So it'll be a special one to this in May. So if you're interested, let me know, because all JUG members will get in for free too. You get free tickets to go. But of course, then you have to make your own travel arrangement too. And then we also are community partner with JetBrains, so that they donate every month. They would donate like 2 free licenses for us to raffle off, the ultimate license. And then also we are partnered with the devitjobs.us. They are online recruiting opportunities if you're interested in signing up with them. Okay, and some upcoming events. So in March, right now we're still actually waiting to hear confirmation of the location, but otherwise then March 12th we'll be having Pratik Patel, and he's the VP of Developer Advocacy at Azul. He'll be here. And then we also have a special guest, Mo Hagigi, and some folks from Discover, John in here. So Mo and John is working with Mo. So Mo will be here too, doing a short lightning talk as well. He just recently moved to Chicago from London, so we want to welcome him here. And then in April, we'll have Jerison Baines, who is also in here. He has his own startup company called Invergence. Did I pronounce it correctly? Invergence, yeah. So yeah, he's running his startup company, and he'll be doing a talk in April. And then in May, on the 13th, we'll have a speaker from Temporal. They are the company that makes, you may be aware, they're spin-off sort of startup from Uber, and they do some very cool like workflow kind of streaming systems too. So. And then in June, I'm planning to do a lightning talk. So if you're interested in speaking, I'd like to invite all of you to submit your proposals too. And we try to accept everybody's proposals, and as long as you keep your talk short, then we can have more speakers too. And other confirmed speakers, we have Alina Urenko from the Ground VM team, but she was gonna be here, but then she cannot, various reasons she cannot be here. She'll be in the US, but cannot stop in Chicago, but she's gonna find another opportunity to come. And then Josie Pamal, who is also an Oracle Java developer advocate, he'd be able to maybe do a virtual presentation. And then also Gerrit Grunwald from Germany, and he works for Azul. He'll be here in September. And then we're still planning an meetup, like a conference style meetup. So if you're interested, please let me know. I'm trying to see if folks are interested and we can organize one. Oh, cool. Yeah, Maciek, thank you. Yeah, I'll remember. Cool. And now, just some more event information. Java 1 will be on March 18th to 20th in Redwood Shores, California. That's the link to the event. And then JUG member will get a discount of $100 off, but not available for public sector ticket. But this is the code for it too, if you're interested. And then Great Lakes Software Symposium, again, will be May 16th to 17th in Chicago, and brought to us by the No Fluff Just Stuff people. And so this is the link to their event. And we have a $100 Chicago JUG discount. This is the promo code in here. And there are also group discounts available too. So say, for example, I think Alexander, your whole team is here, so you can consider getting a group ticket discount. Yeah, so that would be cool. And today, again, we'll have the special raffle for 1 free ticket at the end to the Great Lakes Software Symposium. Okay, if you're interested in speaking at CJUG, please send us email at present@cjug.org. And if you're looking for jobs, or if you are trying to hire people, this is a group that we've created on LinkedIn where you can communicate with one another too. Okay, now we go to the next section, which is just introduce our sponsor again and thank them. Neo4j is our gold sponsor for until June this year. And then actually there will be another raffle too. If you are interested, Neo4j always runs like a monthly raffle too, and they will be raffling off something like a drone. For example, I think this month too will be a mini SE drone as well. They usually do that, or maybe a slightly different model. So if you're interested, you can do that, and then they will be running their raffle at their office, and they will notify if you're the winner. So, okay. And if you miss it, let me know. I'll share with you the slide deck. And here, too, tonight we have our venue host. Thank you so much again to David Giard. And where's David? David, I think, stepped out. So, yes, David was here earlier. But if you see him, you can thank him, too. He's the one that helps us with booking this room. So thank you, and thanks to Microsoft. And also our friends of CJUG, we are really friends with all of the JUG communities all throughout the world, but in particular, the Atlanta JUG, Boston Java User ASEAN Chapter, Garden State JUG in New Jersey, Kansas City JUG, New York City Java SIG, the oldest JUG in the US, and Pittsburgh JUG, Portland Java Users Group, and now also the Virtual Java Users Group as well. So again, welcome folks on the Virtual Java Users Group. And let me go to the next slide, which is to introduce our special speaker today from Land of Enchantment. Anybody knows where he's from? Land of Enchantment.
Walter White's city.
Ah, okay.
If you're into that.
Yeah, so, yeah.
Albuquerque, yeah.
Yeah, thank you. Good. So yeah, welcome, Daniel. Daniel is an independent software professional and a deeply experienced self-employed consultant and developer, providing solutions to private education and government entities since 1999. And he's also a teacher who teaches development and also an international speaker since the early 90s. He's also a co-founder of the Albuquerque Java Users Group and specialties in all these things, as you can see in here.
I need to update that. I don't know where you got that one, but yeah, those are some older texts there. J2EE, that's right.
Sign off to changes on your LinkedIn.
Oh, I need to update that one then. All right, cool.
Sorry, but so all the other technologies too, but I'm sure there are actually many more too. So.
All right, good. Excellent.
Thank you. So the stage is yours.
All right, thank you very much, Mary. Appreciate it. Hey.
Thank you. Take that.
All right. Yeah, can you hear me okay? All right. Just want to mention that also for No Fluff Just Stuff, there's UberConf in Denver. I think Mary will be speaking there. That'll be July 15th through 18th. And you could save $250 if you register by March 31st. Also, I do stuff for Azul as well. I'm not an employee with them, but if you're interested in any kind of JVMs that are less costly than the big O, come talk to me, and more than happy to fill you in on that as well. Let's see. I think that was it as far as the announcements. Let's go and dive right in. I want to start off with a couple of items first, just to make sure that you know about them. One of them is Java Almanac. Anybody know about Java Almanac and use it on a day-to-day basis? All right, great. Anyway, let's take a look here. JavaAlmanac.io. So just a couple of things before I talk about some of the design patterns and some of the things that I think as Java developers you should have. And JavaAlmanac.io happens to be one of those. And I think it's great. For all you old timers, let's go back to memory lane right over here. And what these usually have is you can click on any of the versions here and take a look at it. But what I was going to mention is for some of the old timers here, that if you take a look at, some of this is what the API used to look like in Java. Look at that, and right here. I don't know if I could magnify. Look at that old font there. Yeah. So beautiful. Yeah. So, but you see LTS, EOL, and by the way, again, LTS is the long-term support, but that's usually based on your vendor on how that long-term support is going to be used. But for every version here, you can see you have the API, the language specification, the VM specification, any notes, where to download the JDK, where to download the JRE. Because let me ask you this, if you ever wanted to look up the API, what do you usually do? Right? You just go to Google and say, API, Java API, like, and sometimes you'll get like JDK 8 when you're working on 21, you're like, what is going on here? So what I like about this is that you can get to wherever you need to right away. Like, hey, I'm using Java 21, let me go to the API right away, and then I am good to go, right? And I love that. But what I also love is this right over here, this matrix. So I can compare, hey, what's different between Java 21 and Java 17, right? Common question on there. So this would have like a nice little diff of, what was added, what was removed, what was deprecated, things like that. So just want to make sure that you always have this one bookmarked. I think it's a wonderful Java resource that you can use. The other item is the following. Let me CD over here. How many of you know about MCS as a tool? Okay, we got one nod. Yay, one nod. Anyway, so MCS is a wonderful tool that you could install with SDKman, or just go look for it. It's MCS, Maven Central Search. So when you want to look for a particular dependency, like how do you do it, right? Do you go to search.maven.org? Because no one knows that new website, right? It redirects to the new website. You're like, I don't remember that. Some of you go to what? mavenrepository.org, right? So you go looking for a dependency usually that way. I think you'll really dig this tool here. It's MCS, search, and let me do Spring Core, for example, here. And so, let's say I want to look for that dependency. I could do an MCS search and see how cool that is. It's just right there on the terminal. Now, what I'm going to do is, maybe I don't want to use 7.0.0.m2. I don't trust that one quite yet. So let me go ahead and highlight this, and I'll go ahead and copy that. And let me do another MCS search here. MCS search, but now let me give it a gav in here with the group ID and that. And now I get to see other versions in here. So let's say, I like that one, or maybe I like that one right over here. So let me go ahead and grab this one, MCS search, and I'll bring that one back up here. And there we go. And now I get a specific version, and it ran into an error. Okay, excellent. Oh yeah, there we go. Let's do that again, and MCS search. There we go. Woo! And there it is. And I could also, you just take that, and you could probably do, I don't know if you could do that. I was thinking like, hey, you could pipe that to PB copy or XDG copy. But all in all, I think that's really cool, right? Because you don't have to go like looking and rifling through web pages just to get whatever it is. Okay, so just thought I'd drop a couple of those in there so that way some nice tools that you could use. Now this right over here, this is actually part of a full class, and I'm not going to go through all the slides in here. So what I ended up doing is just creating a little list in here of things that I'd find really interesting for us to talk about in this particular section in here. And I'm going to start off here with factories. For one item about factories is, for many years when we create factories, and I think Java has this bad rep that everything is a factory. Oh, you do Java, so everything's a factory of a factory of a factory of a factory of a factory. But the thing about factories is I think they're important, right? I need something, I need it, created it, I need it lazy. That's the idea of a factory. I think in the old days we did like a class and we had like one method that says create something and we would get something out of it. One thing that I think is, kind of like the way we do things now is that we do lambdas, right? A supplier, if you ever did a supplier in Java, I think most of you have done so already, a supplier is a factory, right? You get something out of nothing and you create something out of it, right? That's already the factory. That's the easiest way to create a factory. So functions have really lightened the load for that. We don't have to create classes upon classes upon classes of like factories. These can just be done using a lambda. But one of the other things that is coming out now is, well, for one, let me start here with static factory. So you take a look at shoot, what is the name of that book? Java, the one where they, let me see over here. Give me a second here. Brain just decided, let's go take a little bit of a trip here. The static factory pattern. Josh Block, yeah, there we go. Effective Java 3rd edition, yeah. So in Java 3rd edition, he talks about the static factory. And the static factory is the idea of you are able to create a static method, which is how you would create things, right? You wouldn't use necessarily the constructor for that. And like something like this, date from an instant, right? That's the static factory. You have like meaningful names as part of it, and that's really one of the cool things about it. Value of, like big integer value of, that's the static factory that we have there. We're creating something for big integer out of a meaningful method, and so we've kind of embraced this. Here's another example here. Stackwalker.get instance from this, and another way that we can create a factory for that. New type, you can have some like files, new buffered reader. So in the Java world now, we kind of do this in order to create objects. This is also a factory as well. So that works out really well for what we are doing. But also there's this new one as well. Let me show you another website that I think you will need as well. This one's the JEP. So if you go to, let me highlight this one, and here we go. openjdk.org, JEP's 0. This is the Java enhancement proposal known as JEPs. JEP 0 is, just what the JEP is. But if you ever want to know what's coming up and what's new in Java, this has it all, right? This is the website that you would need to go to. If we take a look here, we have in-flight JEPs, we have submitted JEPs and draft JEPs. So there's a big list here. But when you come in right over here, these are the delivered features, right? And we can take a look at this list here. Structure concurrency, all this good stuff, linking runtime images, so on and so forth, vector APIs, scope values. But one of them on here is this one. I don't know if you've seen this one. This one's called flexible constructor bodies. So one of the cool things that we are going to be able to do now, possibly as a pattern, is the following. Let's scroll down over here. Well, one of the reasons why we do have these static methods is because something like this, right? If I did this as a constructor, I would have to have like a super call, right? The rule for Java is if I am using a constructor, I have to call super first, right? To call up the chain. But there's a little bit of a load there, right? Because if we take a look at this one right over here, we have value. If value is less than 0, then we'll throw a new legal argument exception. This right here is a invariant, right? It's a rule. I need this rule obeyed, and I don't want to call up the chain all the way up, right? And so what they're going to be doing now, and so this talks about all the different ways that they can go about it. But what they're aiming for here is something like this, okay? And I think this would be official on JDK 24. So that way we could just call, hey, let's check the invariant first, and then we could call the super afterwards. So one of the reasons why we did the static method factory, the way we did, is because we have these invariants, right? We didn't want to call up the stack, plus other reasons as well. So look forward to that as a particular pattern as well. Okay. Let's go on to builder. Ye old builder pattern. Friend of mine, James Ward says, I really, really dislike the builder pattern. I'm like, wow, interesting. I think a builder pattern, it is a creational pattern, very much like the static factory and the factories. But the builder pattern kind of gets a bad rep, I think, as well, but highly useful. I think the builder pattern is not going to go away either. I think it is here to stay. Although how you go about doing it, that may change. And it's already changed a little bit now. So let's take a look a little bit at the builder pattern and wherever my IntelliJ went. Where are you, IntelliJ? Let's see, there's that one here. Okay, give me a second. Of course, during a presentation, IntelliJ decides to take a little vacation. Hey, there it is, not responding. Stand by. I will ignore for now. Let's try it again. Ultimate. There we go. Stand by. Ought to be here pretty quick. Yeah, and there we go. So let's talk about the builder pattern. And let's see, we have a couple of them here for the builder pattern. Give me a second here. All right, there we go. So we are back. Let's see. So one of the items for the builder pattern is the following. So here's an example of one. And by the way, take a look at this date. This presentation is a work in progress. I did this presentation of the Albuquerque Java User Group on May 29th, 2012. Woo! All right, yeah. So this is the classic pattern that I presented that day. And you're probably aware of this pattern as it is. This one is an espresso drink that I wrote a long time ago. I decided to start up the builder with add shots, where you would add the shots for the espresso. And this would return the builder. And here's the builder right over here. Okay. The builder would just carry along. This would just be an object that would carry along the state. What's really great about the builder pattern is that you can call it in any order that you would like when you use it. And if I come in over here for the barista, this is what it would look like. Right, and I think we're all familiar with the builder pattern, the old classic style builder pattern. So this is the way you can call it, right? And that's the benefit of using a builder pattern. I'm able to say, espresso drink, add shots, set it to decaf. Again, if I wanted to, I could move that line up and I shouldn't get a red line on it. Yeah, there it is. And that's really one of the cool parts about that particular builder pattern, okay? But a couple of items that I think probably hasn't really stood the test of time, I guess, it would be the builder itself would return a this. The builder pattern would also mutate, right? And that's the other thing here. I think most of us now have gone into like an immutable style development. So I think this part's kind of not used quite as much anymore. I don't know if I'm correct on that one. But this is the classic pattern. And generally what we do at the end of everything is that we call a build. The purpose of this and the reason why you want to bring this one up is because you don't want a constructor that is 15 elements long or anything like that. You want the ability to pick and choose how you wish to construct things. So that's one way to go about it. But let's take a look at a functional way to go about it, and this one here would be the functional builder. Now, I'm not advocating this is a solution just because it is really noisy, but maybe something to look out for and maybe something to look out for when it comes to the future of Java. And let's take a look at this one. This one's called currying. So currying in functional programming languages is making a down payment in an argument. It's not necessarily a builder, but I think it is a kind of a cousin or akin to the builder pattern in that it is a creational pattern and you're doing, bits and bits and bits and you're paying down payments on it. So what is the down payment here? This is a little bit verbose here. And again, I'm not necessarily advocating it just because I don't think Java's quite there yet. But the idea for this is, hey, if you give me a string, which will represent the first name, then what I'll do is I'll return a function back to you. And given that function, if I give that a string, then I'll return another function. And if I provide that a string, then I will provide the construction on here. Downside or disadvantage on this one is you have to go in order, right? So first name, etc. But you get a function. And one of the things you find about functions is that you can carry over that state. So in other words, if you plug something into a function, it kind of holds on to that state, which is kind of like a neat little thing about a function. And when you get that object back, then you could do something else with it. So you could essentially do kind of like a forking. Let's take a look at that. So let's say I have this record person here with a first name, middle name, last name. And right over here, what I'm going to do is I'm going to apply the function one round, and I'm going to say Thomas. Well, that's going to return a function that returns a function, right? Now, let's say after applying the first name, I'm going to apply the name Falco to it. Well, that returns another function. Now I'm going to take that function, remember it's holding on to the state every time I apply to this, and then what I'm going to do is apply a last name to that, which will be Dolby, and then finally I'm going to get the person out. Okay? So making down payments along the way. But what's really cool about this, and what I like about functions, is let's say this applying first name, which is this reference right over here. If I apply, and so after applying the first name, this is already Thomas, and this is already a function that is holding on to the name Thomas. Well, right after Thomas, I'm going to apply Rogers and Stevie. So if I run this, maybe, then we should see the same first name on each one of these, Thomas. One is Falco Dolby, and the other one's Rogers Stevie. I really like that, right? I like the way functions are able to hold on to state. You give a down payment, and you could reuse that multiple times over. And that's going to be like a recurring theme when we talk about functions in Java. Okay? So cool. How many of you use, what was the name of that? And I hardly ever use it. For Lombok. I had to look it up, okay? I'm not gonna make a claim on like, hey, I love Lombok. I'm not gonna go down that route or not, but I particularly don't use it. But one of the cool things about Lombok is, well, you know, creating the builder pattern that's a lot of work to it. So one of the things about Lombok is that they have a builder annotation, and here's what that would look like. So instead of creating all that code for you, one of the cool things that you are able to do with this is, here's that builder pattern again, but one of the cool things that you're able to do about that is this, right? And so whenever you create a class, you could say @builder, and then you could have a default value associated with it, name and age, and you could have something to where you can set up a multiple like occupations there. And that would take care of all your builder stuff for you, and that way you would end up with a builder pattern. A lot of people love that, and I think that's a great utility there. So another way that you could take a look at that. Here's an example of a builder, but except this time the builder is returning a immutable object. So in other words, this time, a different take on that builder pattern is that I'm going to set, like, let's say, for example, here, I'm going to set the name, and notice what I'm returning here. I'm returning another builder object back out. Immutable this time. Remember, the classic one was mutable, and it kept saying return this, return this, return this. This one, on the other hand, just returns a new object for that. Okay, so this one has name, capital, demonym, which is name of people. So Chicago is Chicagoan, right? That's a demonym, population, and currency. A different take on that. And you've seen this before. Maybe. Maybe you've seen it before. Let's do JShell right over here. Right? I argue that this is a builder pattern, and we may have seen it before. Here, let's take a look right over here. like list 1, 2, 3, 4, 5 dot stream, right? It doesn't have to be called dot builder or dot build, but the idea from this is if I do list of 1, 2, 3, 4, 5 and then dot stream on this, I end up with this, right? And all of us have done streams before, and if you've ever run JShell, this is what it says, right? A Java util stream reference pipeline, blah, 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 right? That's a reference. And what do? You just add elements in whatever order that you want, right? Not amp, but map, right? And if I do x times 2, for example, I get another reference from that as well. But notice it's a different number, right? It's a different reference. So that's the immutable version of, to me, that's the immutable version of that builder. You're getting a different reference in return. Cool, right? All right. And then finally, when you call, to list here, this would be same as like that dot build. Okay? This would be an immutable version of a builder and has a lot of applications for that. So your classic builder is going to look a little bit different because of that. Cool? All right. Groovy. Although we're not talking about Groovy, but. All right. So builder. Singleton pattern. On this one, let's go with, let's see, where should I start with this one? I think this one is probably that one design pattern that has given a lot of people a consternation, just like, oh, yeah, that single pattern. There was a time, probably early 2000s, if I remember correctly, that singletons were so prevalent, and I think oftentimes misused. Particularly, they would create a singleton, and they were like, oh, we needed multiple objects of this, or and we kind of locked ourselves in. Singletons are still being used, but the way we use it, I think, is vastly different now. I don't think we use the pattern quite that much directly. How many of you have like singletons now, like the classic style singleton pattern in your code base? What's that? A couple, okay. It probably was more prevalent before, but now we did that down to a couple. They were tough. One, they're hard to test, just because they had their state, and sometimes you would have to use an annotation to say, I want to make this visible for a particular test, so that way I could get into it. So that was always one big problem with the singleton. A little bit hard-coded. Well, not a little bit hard-coded. It definitely was hard-coded. Written incorrectly as well. They didn't put a synchronized block or any kind of lock associated with it. So if you ran this, with multiple threads, then that would be an issue. There's this wonderful guide, Misko Hevery testing, and let's see. I think he is. Yeah, it's right over here. So it's a wonderful little book here, Guide to Testable Code. Have you ever seen this one? I think this one's really good. And if you want the URL, you could either take a picture of that now or ask me after the talk. But this was a list of PDFs on how to do testing. Misko Hevery went on to do Angular. So if you recognize that name, he's now in Angular. But before that, he was with Google, and he was doing a lot with testing. And so he has this one in here for like flaw, global state and singletons, and what's wrong with singletons, and how dare you do that, and why did you do that? But all the same things that I was discussing here. For example, let me see if I could scroll down on here. Yeah, like this one on here. This one's hard to test. You'll notice over here, let me highlight that, I have a visible for testing, right? That's the way to get into that state, so that way you could test it. That's a lot of hard work. And if you're spending a lot of hard work on your testing, is it worth it? So there were a lot of things with singletons that made it kind of tough, but we still use singletons. I use singletons in Scala. It's actually a big part of Scala to create a singleton. It's called an object, okay? It is a construct that is meant to replace static, and we use it all the time. And it's not really that bad because it's not really exactly the same thing as this. But for all of you who do Spring Boot, right, you do what? Add singleton on top, which is what it should be, right? If you want one object, Just use it one time, right? You don't have to go through all that extra ceremony in order to do that. So singletons are still there, probably not as much as a pattern anymore, but just make sure you only use it once. Use that in your Spring or use that in your Juice or whatever dependency injection framework that you would like to use. Okay. All right. Now, let's go to functor, monad, oof, and filter. Uh-oh. Have you heard these terms before? Right? Nerds will use this term quite often. Right. Nerds will use these terms quite often. But I think they're a fundamental principle, and they will be from here on out. So let me come in over here to, let's see, I have one here called functional. Here we go. Here, let's discuss monoid first as well. You might be hearing these terms. If you go to Kotlin, definitely if you go to Scala, you'll be using these terms quite a bit. Is it going to cross over into Java? I think so. Yeah, you have a definite yes? I have a, yeah. That's right, and I'm going to talk about optional, right? We kind of see this. You know what? I'm going to go with your absolute yes on that, right? This right here is a monoid. Doesn't look too scary, does it? Some of you are like, yes. Yes, sir. A monoid just joins things together. And what is your natural gut reaction to if I say a monoid of integer? What would be the implementation? It would probably be a plus, right? If I want to join two integers together, your gut feeling is like, yeah, that should be a plus. If I say I want to join two strings together, what would that be? Concat, right? That's your gut reaction to it. Well, this defines what that gut reaction is, or whatever it is that you need from it. So monoid of string would be the concat for that. But in more general abstract form is what a monoid is. To me, these are functional patterns. These are patterns that are in use greatly in functional programming languages, and I think they'll, or they are currently available. What is a functor? Well, here's the definition of a functor. Functor sounds like a robot at a disco to me. I'm functor, but here's what functor is. Functor is map. So when you use a map, you're using a functor, okay? So that would take a function, typically from an A to B of some sort, and then return a B from it, okay? Which is, this, right? This is the way we use a functor. We just don't, we're just not explicit about it. Functional programming languages will use the term type class to define it. And I'm kind of doing a type class here. Notice what this is. This is a type class to where I am using a collection of A. One of the things we don't have in Java is a notion of what's called a higher kind of type. I'm going to scare you with a bunch of terms. I don't know if you know that, but we'll take it easy. But a higher kind of type is when we describe generics, we usually describe generics as, something like this, collection of A. Right, and A represents whatever, right? That's the generic form or the parameterized type that we're talking about. But in languages like Scala, and I kind of have that up there, I could say, I'm going to make a generic type for the collection or the holder of that. That's f of A. So you mentioned optional. Optional of integer has that form. That's what the higher kind of type is. It's creating a generic around that f there, okay? Optional of integer has that form of f of A, right? In functional programming, we generally use this notation here called the star notation, right? That if we have this f in here, we could resolve that, then we could resolve that, and then have like a concrete type like optional of integer. And if you think about these forms, you see them everywhere in Java, right? Observable, if you've used observable, or maybe flowable, or maybe flux. Future has that type. List of A or list of integer has that type. Set does, but it doesn't follow some of the rules, so we'll leave that one out. But a lot of these have this kind of like pattern to it, okay? Map doesn't. Map doesn't work because map has two generics, right? So it doesn't have that shape, right? Like list of integer has that shape, but map of integer and string doesn't have that shape, okay? Maybe we'll have that in Java, and I don't think it's that spooky, but that's how that would work. Monad, let's tackle this big term here. I consider this a pattern, one that I think we would need to be very well versed in. But a monad is flat map. Boom. Most people like take this long road as to what a monad is, but a monad is a flat map. So when you use a flat map, you're using a monad. When you're using compositions of flat maps and maps, that is you'll hear that term, monadic composition, right? Don't get scared about that. You're just using flat maps and maps together in order to do things. You ready to dive in on that one? Okay. Don't let it scare you too bad. But here, let's talk about a monad, and we'll go here to this monad test on here. Well, let's see, what should I do? Well, here's an example of monoid. Show you what a monoid is. Here's this one here called join all. And here's how a monoid would work. See that monoid there with E? Monoid just means bring things together. So all I'm going to do here is going to bring in this list, and I'm going to bring them in together and have this result. So if I do list 1, 2, 3, join all with this list, and this right here is kind of a strategy, which is how am I going to bring things together? Okay. And that's where this comes in. And if I take a look at the implementation for this, here it is. String monoid of a string. How do I bring two strings together? I'm just going to concatenate them. Okay. And if I go ahead and run that, all we'll see here is that, they were just concatenated. But this right here is a strategy on how to join things together. And that's what the term monoid means. Here's functor. You've used functors before. You could leave today and say, hey, I know what a functor is and I've been using functors. That's what it is. It's a map, okay? And so that looks pretty cool. But every time I'm going to talk about like functors and monads and things like that, there's a good side and an evil side to functors and monads. If I say a non-evil or a good refrigerator, what comes to mind? What would be a good refrigerator in your opinion? It has food, right? But an evil refrigerator would be like, you open that up, you're like, oh, there's just one Red Bull in there, right? Or it's like it's totally empty. So when you design programs, and this is what we have in Java now, is that if you're composing things together and if anything in that chain is empty, the whole thing's empty. And if you think about that, you get validation as part of that, because if anything's empty, the whole thing is empty. Think about that one as well. This is what a principle of monadic functional programming is. It is a pattern, right? If anything is going to be empty, the whole thing is empty. So here's this one. And you could tell, right? 1, 2, 3, 4. And here, let me go and run this one. 1, 2, 3, 4 multiplied by 10. I should get 10, 20, 30, 40. But if I have a stream of empty and I'm running a map on this, no problem. I'll just return a list, or the answer will just be a list, right? An empty list. If you think about this, right, we've been doing try catches for so long that, having something like this that doesn't like disrupt your code may seem kind of odd, right? But that's the idea for this, is that I can run a bunch of flat maps and maps. It's non-disruptive. I just get an empty whatever collection that is. And that's another principle of this monadic style program. And here we are, right? As said, we have Optional. Optional typically has that shape, right? Something of something, optional of integer. And in this case here, I have an optional of 40. I want to do a map on that. Well, what am I going to get in return? Well, let's take a look here. I'm going to have a optional of 400. Kind of cool, right? I get to keep the outside shell of optional. I'm just changing what's inside of it. Or at least that's what my perception is. Okay? But same sort of thing is if I have an evil optional, right? Whatever chain I have on here doesn't really matter. I'll get an empty optional from it. Again, I don't have to put try-catch blocks on this. That's part of that monadic style of program. Okay? Here's is this a bad monad? No, this looks like no, I think that's a good one. I don't know why I called it a bad monad. Oh, I know why I called it a bad monad. All right. Let's talk about flat map and monad. And hopefully it wouldn't be too scary. If you've used flat map before, you know that on my line, 82 over here, stream of map, where I'm going to take a x, what usually you want to look for is when you have a map, here it is, if you have a map and you have a function to where you take one element and you return a plural, that's when you're going to need a flat map, right? And I think many of you have already have the eye for that, right? Oh, there it is. I know I need to do a flat map on this. Because you're doing a map and you're getting a single element and essentially, poof, you're exploding it, right? For one element, boom, I'm creating another stream from that. And you end up with a stream of a stream on here. Well, if you don't want the stream of a stream, and again, sometimes you'll just fall into it, you're trying to do a map and then the type on the left-hand side ends up a future of a future or stream of a stream or something like that, then what you typically want to do is you typically want to flatten it. And that's where that monad comes in. Okay, so you've been using monads up to this time. Maybe you didn't know about the name for that, but the idea here is, I'm able to crush that. So for every element in here, I'm exploding it, negative x, and x plus 1. That's a monad pattern, right? Not part of the classic design patterns, but part of the functional design patterns. And if anything is empty, and if anything within that chain is empty, the whole thing is empty. Okay, it's pretty cool in how that works. And then finally over here, what I have is, or I guess I have a couple of more items here, is that this is an arbitrary example in here. But one of the things that you could do with this is, let's say I have a stream of 10, 1, 20, 0, 5, and 25. And I'm going to do 100 divide by that number. Now, yes, I could do a filter beforehand, but maybe I don't know what's coming up. Like right here, I could see what's coming up. But if I don't know what's coming up, and one of the numbers is 0, well, what I could do is I could use a flat map in order to filter out bad elements. So in this case here, 100 divided by 0 will throw an exception, and that will be an empty. And one of the things about a monadic style programming is, if any element is empty and you flatten it, you end up removing it. Okay, nice little feature to do monadic programming like that. Here's another composition in here. In fact, this one is a very important one. This one is the true monadic style programming. And it is flat map, flat map, flat map, flat map, flat map, flat map, map. And then maybe a filter is sprinkled in there or so. But the notion of a flat map, flat map, flat map, flat map, flat map, map is that monadic style of doing chains of items together. Okay, this is present in Haskell. This is present in Scala. I think it's probably present in Kotlin as well. And that is flat map, flat map. The last one is always a map. You could chain equal elements together. So if I did, let's say, for example, optional dot of 20 on here, notice what this is looking like here. I'm going to take 30, x represents 30 here. I'm going to take 20, y represents 20. Here's 10 right over here, and z represents 10. And I'm going to add these together. Okay? How many of you use IntelliJ for your editor? I don't know if you knew this, but variables that are closured are purple. Did you know that? Like taking a look like really deeply at it. So I have a hard time looking at it. Yeah, X and Y here are closured, right? Because this function right over here is closing around X, just because it's nested like that. And Y is closured as well. That's why that's purple. Okay, maybe hard to see on this screen over here. But what's really cool about this is that this is the way that we chain things. Okay, that's the kind of pattern. Okay, so flat map filter. How many of you in your code base do you have the observer pattern still, like the old classic observer pattern? Used a lot in GUIs. The idea for an observer pattern was you would broadcast information. This class would say, hey, I got this new element, and others would be notified for it, okay? And that's the classic observer pattern. I think still very useful in user interface programming. Iterator as a design pattern. I don't think anyone's ever made their own. You've just used Java Lang iterator, right? That's the iterator pattern called next and has next for that. Let's take a look at the classic style observer pattern, see what that looked like, because I was just waving my hands on that one. Let's take a look over here, and let's go to observer classic. And yeah, I think, let's see. Here, yeah, here's the brunt of it here. So what I could do with this is I could do the following, right? This is registering a listener, RSS observer, okay? And what I could do with this is, I could add the observer here. And a friend of mine, John, wrote this, and he's just returning the observer back. I could return observers. This is like a newspaper publication or an RSS publication where you register observer. And if this RSS feed has anything to talk about, then this would just say, yes, ta-da, here it is. And anyone who is interested in me can get the information. That's the observer pattern, okay? Kind of nice. This is the classic observer pattern. The iterator pattern is of course, a interface that has next and next. Do you have something for me? Great, give it to me next. Do you have something for me? Give it to me next, right? If you've ever done result set JDBC programming, that's a iterator. Okay. So what would it be if I combined, I feel like a candy bar commercial, what would it be like if I get the tastiness of chocolate and mix it with peanut butter? But this time, let's take the tastiness of a observer pattern, let's mix it up with an iterator pattern. Well, this is where I think one of the patterns that we talk about a lot nowadays is the reactive pattern. How many of you use like an ArcsJava or Project Reactor at your work? Okay. This is what I'm going to explain to you on this one is the reactive pattern. This is an Arcs pattern as well, very common in a lot of programming applications now. One of the things that it's undergone as of recent is because of Java virtual threads. One of the things that is often talked about now is the reactive pattern going to survive? Interesting. So what's the deal with this? Anyway, this is both observer pattern and iterator pattern. And I think it's really cool. My opinion on the whole virtual thread's going to kill off reactive is I really don't see it. Because one of the things about the reactive pattern, it's also a great event bus. Okay, so if you do any kind of like DDD style programming and you have like two aggregates or two, parts of your software and they need to communicate to one another, this offers a really wonderful channel in order for it to do so. But the reactive pattern is able to do a couple of things for us. One, serve as a event bus. But the other one, which is the one that's under contention right now, and that is handle threading issues. Okay, But here's an example of, I love RxJava. RxJava is just a competitor to Project Reactor for Spring. But the idea here is that this is an observable, and I'm going to say on next 100, on next 140, on next 290, on Donner, on Blitzen, on 10, and etc. And I'm able to state here on next, on next, on next. And then at the end of this, I'm going to say on complete. Generally for an Rx pattern, it's on next, on error, and on complete. Okay? Those are three elements that we emit. And so this is an observable, which is a thing that is emitting elements. Now, what I could do with this is I can stem from this and do something with it. Now, why is this a benefit? Well, I don't know if you knew this. Here, let's play a little game here. Game with J Shell. All right, here we go. I'm going to do list of string. No, no. Let's do this here. List of. Here, let's do var s here. List of 1, 2, 3. And let's do a stream on here. And there we go. Or not. Oh, list of. I know Java. All right, here we go again. Hey, there we go. Hooray for me. All right, so let's say I'm going to do the following. String map. I'm going to take each number and I'm going to multiply by 4. If I hit enter right now, will it work? Yeah, sure. Yeah, right. So far, so good. Let me take that reference S now, and let's do filter, and I'm going to filter all the, I don't know, even numbers. Nope. Here we go. Is this going to work? No. Illegal state exception. So one of the things about streams is that you can't fork it. And this is a fork right here. Right? S and S. Can't fork it with a stream. And that's by design. Okay? But what's cool about reactive, but you got to pay the toll somewhere, you can fork this, right? And so if I run this one, you know, I get to see one set being done and the other set being done. Okay? And that's awesome with a but. And the but is if you're running this on multiple threads where the source is on one thread pool and the sink is on another thread pool, you may suffer what's called back pressure. Okay? Back pressure is if, you know, I go to you and I say, write this down, and I go, right, and I start like saying a bunch of words very fast, and I'm asking you to write it down. That's not fair to you, right? That's a back pressure because I'm running out of oxygen. The endpoint's not writing things down or consuming very quickly. That's a back pressure issue. And so that was one of the things that Java said, you know what, we're not going to handle this at all when it comes to a stream. So you can't fork a stream. But you can fork this. But again, you have to pay the toll somewhere. And that toll is you got to think about back pressure. Okay? Here's one of the benefits as to why we have this pattern, this reactive pattern. And here it is. We get to do bulkheading with it. Just about everything in your job is this. I/O, like this part right here, should be on an I/O thread because you usually get something from a source, right? RESTful endpoint, right? That's I/O. Go to a database, right? That's usually I/O. And then the rest of the stuff here is usually, and I'm just hand waving here, but usually the inner stuff is going to be computation. And then at the end of it, you do something I/O, store it to a hard drive, store it to an S3 bucket, or do something with it. Just about everything we do at work is I/O, computation, do something with the payload, and then I/O, put it somewhere else. Okay? So that's how this works with this particular, what I call a pattern. Let's see. And I love this. These are called marble diagrams. This is the observe on. Take a look at this one. See that black arrow there? That's the thread that we're currently operating on. But observe on says after this step, jump onto a different thread. And all I had to do was do this scheduler on here. So this says, let's start off with 1, 2, 3, 4, 5. At this point here, let's jump over to a computation thread. That's what that means. Subscribe on, let's take a look at the documentation for that one. Cool. Well, that one says, if you hit me as the operator, then what I'm going to say is I'm going to dictate to the source of it all and say you should be on this thread. And that's what a subscribe on is. Project Reactor and Spring works the same way. So this means start at the very beginning on I/O. This means from this point down, minus the subscribe on, make sure you're on the computation thread. And this one on here, just make sure that we're on the I/O thread. And I think it looks beautiful, right? Because you're just able to programmatically declare, boundaries of threading, okay, using what's called a scheduler, okay? Sorry, I was calling myself names here. I was at a low point. All right, excellent. Okay, hopefully not too nerdy for you there. Okay, adapter pattern. So on these ones here, particularly the adapter pattern, I think many of us are familiar with the adapter pattern. Think about like the European plugs and the American plugs when you're trying to, connect into an outlet, depending on what kind of outlet that is. Use an adapter for it. Same concept when it comes to Java and this particular pattern. It can go through a different kind of reimagining for it. And we could use lambdas in its place as well. So let's take a look at the classic pattern first here. And let's take a look. So I got a couple of adapters here. Let's take a look at this one here. And I think my friend John wrote this one. Here's Celsius. And here's Fahrenheit. Okay, a couple of interfaces in here. This has a temperature in here. And here's the adapter. The adapter is, and so the format of this one is, you're going to bring in a class. So I want to convert Celsius, because that's not a real temperature scale, right? Am I right, people? Anyone here use Celsius? Damn straight. Oh, everyone's like raising their hands like, oh. My thing is, I think, just an opinion on my part, I love Fahrenheit. Sorry, virtual jug. Everyone's like, but I love Celsius. Because like 0 is like, I'm cold. 100 is I'm hot, right? For like the human condition, that's like perfect to gauge. But like Celsius is like at 16. Should I wear a coat? Right. That's not true. I mean, if you're born with using a certain scale and raised using a certain scale, you're going to know that scale very well. Anyway, so let's do a conversion in here. That's what an adapter is for. Okay. So if I bring in this Celsius thermometer in here, I could get the temperature in Fahrenheit. See how this like plugs in very nicely like an actual electric adapter? Like you go, out of the country and you use that particular adapter. That's what we're fitting over. Okay. So that's the classic adapter pattern. Now, one thing I just want to mention here when it comes to the adapter pattern is that the method names are generally different. That's one of the characteristics of the adapter pattern, okay? Like get temperature in Fahrenheit, you usually have something else. One other great reason for an adapter pattern is if you inherit code in a different spoken language, the adapter pattern really shines there because you get to name the methods whatever you want. That's the idea for a adapter pattern. My reimagining of this is the following. We are in the midst of really embracing value objects as of late, okay? This is a different shift in what Java programmers are doing. And this right here is a value object. DDD proponents, domain-driven design proponents, use value objects all the time. There is a JEP coming out. This one's going to take a while. This is part of project, is it Panama? Valhalla, yeah, thank you. And what that one is, I don't even know if it's on here. Larval state. Is that right? That's an interesting term on here. But the larval state of value objects. Well, there's not. Let me see if there's another one here. I wasn't looking for the larval one. Let's see over here. Value. They don't have another one here. But one of the items, I'm just kind of surprised they removed it. Or maybe they didn't. But the idea for a value object is that you have a wrapper around something like this int in here. We're going to be doing that more and more, and maybe you already have. Those are called value objects. One of the things that we use value objects for is to get rid of a code smell called primitive obsession. I don't know, anybody know about primitive obsession? Like if you have like person that is like string first name, string last name, string social security number, right? Int age. Those are kind of like bad member variables because like int age could be like negatives, zeros, right? And there's like a whole space of like what it could be. Value object kind of constrain, right? And that's a good thing. So Celsius, would have a value in here. But right in here is generally a good place for that conversion. It has a home, it has context. This is where I would do a conversion on here. Here's the Fahrenheit in here where I would do a convert to. Yeah.
I think that'll jump.
Java X time. Okay. Oh, okay, right. Yep, absolutely. One of my favorites and what inspired me for this one, it's a weird name, but it's one of my favorite projects, is squants in Scala. And I think you'll find a lot of beauty with this one. I do. I'm, really impressed by this. And you can see the value of a value object here. Even you may not be familiar with Scala, but I think this is fantastic, right? This is thanks for asking that question because now I'm inspired to just show you this. And that is val, which is like our var, load kilowatt 2.2. You see the primitive obsession here? 2.2 of what? And that's just a variable name. Is anyone going to stop me, right, from, ensuring this is a kilowatt? No, it's just a double number. No one's going to stop me there. Energy, megawatts per hour, 24.2. It's a double. Who's going to stop me, right? And then here's the who's going to stop me part. Sum in kilowatts. Well, that's incorrect, right? If you ever done calculus or physics, particularly physics, right? If you don't put the labels on there, you're on your test, that question was marked wrong, right? Because you may have ended up doing this. Well, this one is where it talks about type safety, and value objects are a great thing and to think about when you're designing. So this one on here is kilowatts. This has a new implicit on here. New kilowatts 12, new megawatts 0.023, and this has an operator overloading, which I think is cool. And I could add this load, which is a power. I could add this load, which is a power. Internally, though, one is a kilowatt and the other one's a megawatt. But it'll take care of that for you, right? And it will do all of that particular work for you. Well, I'm using that inspiration here when it comes to this one, to where I could just say a convert to. So that way it would look like this. So how you create your adapter pattern may change from the classic design and more in favor of like the value objects, because this is the way this would look. I have a Celsius, and then I would convert to either Fahrenheit or Celsius. How would this convert to look like? I didn't even talk about that. Well, this one right here is using some new features, right? And this one's using the switch expressions, not statements, but expressions. In that, after this switch gets resolved, whatever the answer is gets returned. And one of the things I'm able to do here is ask, well, if it's Fahrenheit, this is what the conversion will be. If it's Celsius, this is what the conversion will be. Okay? So some new ways to go about it. Okay. Bravo. Let's do decorator pattern. And I'll quickly go through some of these in here. Decorator pattern is, to me, one of the, and this one's a silly example, but let me explain why you would want to use a decorator pattern. You may have heard, hey, let's use a decorator pattern for something. But the question is why? Why would you do that? Well, here's just one example here. This one is using a sundae, and here's the demonstration in here. This is the old classic pattern where I could have like vanilla ice cream, wrap it up in a whipped cream sundae decorator, and wrap that up and decorate that in a fudge sundae, and then sprinkle some nuts on that. There we go. And then later on, we could add a cherry on it. You kind of see here that we're adding layers and layers and layers and layers and layers on it. And then by the time we roll this out, by adding all these wonderful layers together, and we have nuts, fudge, whipped cream, vanilla ice cream, and we could add and add and add and add to it. So cool. And that's a fun, silly example here. Here's the way it looks with functions. Ooh, let's take a look at this one. Oh, but what's the key thing for these decorators? They have the same methods as opposed to the adapter. All of them have described sundae. All of these have a described sundae because they all inherit from this. You have to call this method. Or I'm sorry, does it get decorated? Oh, I guess this one doesn't. But they should have that same one. Is that the right one? Or maybe it's this, oh, there it is, describe sundae. I was like, where's that interface? But they should all have that same method. But here's the functional one. And like a lot of these patterns, you could just do with a particular function, okay? Or with any kind of function. This is the same sort of thing. This is called functional composition. And where the good stuff is 16 through 18. This decorator is, let's take whipped cream and then fudge and then nuts. Nice, right? And it looks good too. What do you want to do with this ice cream? Well, I want to put whipped cream on it. And then I want to put fudge on it. And then I want to put nuts on it, right? How clear could it be here? And that's me decorating it. So what I could do then is take this sundae, or let's rename it to sundae decorator. And then here's that whipped cream, and then fudge, and then nuts, and then just, hey, here's vanilla ice cream. Go and decorate it. Cool. And then it just goes through this functional chain. Beautiful. Now, while that's a fun, tasty example, this is a presentation that I talk about, and this one's called Testing the Undesirable, and that's me with a beard. I got rid of it, and it's actually Microsoft's fault. Sorry, I'm going to have to ruin your sponsor there, Mary. But I had this beard, and Microsoft had this thing called like Guess My Age. And I don't know, I forgot how old I was in this picture, but I submitted it, and it added like 12 years to me, just because I had that frosty beard in here. But anyway, let me come down. Sorry about all this in here. Let me go to the good stuff here. And it is called wrap, I believe it's wrap method 2. Let's say this is a bank and I have a deposit in here. One of the principles in software is the open-close principle, which is open for extension, close for modification. I'm like, what the heck does that mean? Well, my interpretation of that is write your software for what your need is, and make sure that it's extensible. But when making a change, don't be hasty about it and just like start changing that piece of code because you worked very hard on. And so here's an example here. The need is we need to add auditing to this bank, right? Food bank on here with this particular deposit. Well, one of the things that we can do is we have the deposit. Now, one of the things that we could do is we can change the code, but we want to keep the interfaces because that's going to, blow the rest of the application up. So I can add a audit in here and add whatever kind of auditing that we need here. So that works pretty cool. But we could also use what's, I meant to do a wrap class. Here it is. So I want to make an audit on this deposit. So what we could do is we could extract the interface. I don't know if you've ever seen this maneuver here, but for this object here, I could extract the interface for what it is, and this would have a deposit. Now I could have my logger, right? Open for extension. I'm extending it by, implementing this interface. And then what I could do is I could do TDD on this and do the auditing. I leave the original class alone. That's the best part about this. And it almost feels and looks like an adapter, but this is going to be decorated one on the other, right? I'm adding auditing. So if I want to use Kafka or Pulsar or whatever and send information to it, I could do so. And here's the logger, which would be, the original, which is this, but the auditing would be included in here. And what's interesting about this is that if you tie this into a UML diagram, you're like, oh my goodness, we just got the decorator pattern, okay? Highly, highly, highly useful for that. But again, we could lambdaize it. Let's see, we're at 7:32. Mary, what time do you usually end? Okay, now I just have my list here, so just wondering. Decorator pattern, one of the interesting things about it is that there's also a composite pattern. Here, let's take a look at the UML for that one. I don't know if you've seen this before, or even if you agree with me. Let's go, I think I have the UMLs for that one. Give me a second here as I look for it. Well, here's a decorator pattern. That's the way it looks like, the UML for that, which kind of looks like that one I was just showing you with the auditing. But that's the way that looks like. I have the interface, I have the decorator, I have the concrete component, and a concrete decorator, which will use that decorator, okay? And I could just layer things together. It's like add auditing to a component. But if we take a look at the, let's say the composite pattern, here's this one, this one, this one, this one, right? I'm taking a look at these two together here. They look very similar, right? A little bit. And they are. So a composite pattern is a decorator pattern, except it has multiples. That's the idea for that. So if I go to one component, that one component can send to multiple items. Let's show an example of that. So right in over here, let's show a composite pattern, which really is a decorator pattern, except multiple items. When would you use that? Well, let's say I have this. Here's an example of it. I have a repository on this. Now you can probably see that. See, there we go, a little bit better. And whenever I want to add an employee to this as this decorator, I am implementing a repository in here. But let's say I have a list of repositories that I want to post to. Okay? All I have to do is have that same method in here, but what I could have is a collection of repositories. So if I want to store to, MySQL and Oracle and this and this and this, I don't have to change the interface. That's part of what this composite is. And so as long as I provide that list of implementations of that repository, I could send to, multiple data stores for that. But to me, it's still a decorator pattern, except you just have multiples of it. But what about a proxy? I don't have a really good example for a proxy, or at least I don't think. I have a few of these in here. And let's see if this one here. I have a database, and I have the proxy to a real database. But in the end, if you take a look at this UML diagram, a proxy, which is just a remote call, it is a decorator with a remote call. Okay, on one side, you're holding on to the real connection, and on that client, you're doing something on behest of that real connection. But it's still based on a particular interface, okay, with the proxy and the real database. You're extracting an interface, you're using it like a decorator. It's just a different style of that on how you use it. Okay, whew. Nerdy. Let me jump to state and interpreter, because those are big ones here. And I got a really good story for state. So have any of you seen cyberdojo.org? Cyberdojo. Let's take a look. Cyberdojo.org. If it comes up. Cyberdojo is a website that you can do TDD with other groups of people together as a team across the world. And it looks like it's not coming up unless I got this wrong. Cyberdojo. There it is. So what's cool about this is you can say, create a new practice here. And let's say FizzBuzz, right? Everyone knows that one. Write a program that prints the numbers 1 to 100, et cetera. Okay. So I did a class for TDD, and it went okay, but it didn't go great. And I don't mind telling you my failures, because we learn a lot from our failures. And I said, you know what? Choose one. I got all egotistical about it. Just go ahead and choose one, and we'll do it together. We'll solve it. And they were like, okay, fine, tennis. And I'm like, choose a different one. No, I'm just kidding. We did tennis. And if you play tennis, this was just, how do you do the scoring, right? Love, 15, 30, 40. But you kind of tell where like things started falling apart, right? The 40 part. The 40 part is just crazy, right? Because it depends on who your opponent is, right? And what score they have when you get to that 40. If you're even matched at 40, and let's say I win, then I win. No, I don't. We go, so it's in from deuce, and if I win, that goes into advantage. But if I am at 40 and my opponent's at 15 and then I win the game, right? And there's this like twist here. Everything was going fine until that last part. And I knew something was wrong because we had like a bunch of if-else statements in our code, and we were deriving it with TDD. So we got ourselves in a pinch, and that's the way the day ended, and I felt kind of bad about that. But it's one of those things that I think all of us know this. When you have a hard problem and you walk away from it, how long does it take you when you walk away from it to solve that problem? Right? Just 5 minutes, like, oh, what the heck happened to this one? You walk away and you're like, oh, that's what it was. Anyway, I was in San Francisco. I'm on the ferry and having a beer, watching the water. And I was like, oh, state pattern. If we had just used the state pattern, we wouldn't have had all the if-else statements. Like, that's what that's for. And I knew it, but, sometimes when you're in the middle of something, it's hard to see that solution. So here's an example of this one here. And here's the classic pattern where I have context and I have execute. This is representing an on state. So the idea for a state pattern is that I have a class that represents a certain state. The benefit for this is that there's no if statements on here. You just focus on that one state. And see how easy that is to implement? When you're just focused on that one thing, what should an on switch do when you execute it? That should just be off, right? That should just be your next state. Sorry about that, I keep moving, getting excited. And if I take a look at the off state, what is the next state? This is just like an on-off switch, right? Off. If the switch is off, then the next state is on. You just bring focus onto that one state. Now, the classic pattern has this weird little thing called context here. And the problem with that is that it's mutable in here where we have that switch state in here. So, maybe we could do something a little bit better with it. But here's the run in here. And yeah, what we're able to do with this is, create a state and determine what the state is. So if I have on state and I hit execute, then the state I should get here would just be off, right? That makes it easy. But I was like really bummed out that we didn't have like a perfect TDD session. So I decided, you know what? What would a modern state pattern look like with all the wonderful new amenities in Java? Now let's take a look at this one. So what I have here is I have love. Don't we all, right? And so the idea for this is I'm using switch expressions. I'm using seal types for this. So what is this sealed on here? Let's go to score. This is using the new seal type. So a score only has these states in here. Okay, have you used these yet? These permits? They're wonderful. So this one is, I have an interface, but I'm going to dictate who the children are. And they're going to be used for pattern matching. So what I decided to do here is have a score for, and have children of advantage, 15, 40, love, lost, that sounds horrible, 30 and 1, right? Those are the states of tennis, right? Every player should have that. So I thought, ooh, man, this is gonna look really nice. Yeah, let's see how this one looks. Now, I like to focus on love. So let's take a look at love here. Love is a score in tennis. And if I just want to think about the logic of love, then I just focus on that, right? No if else statements on here. I just focus on love. So right in here is what happens if if there's a win and the opponent's score is this score. Well, I did something a little, and I did do this intentionally. If my opponent won, then it's invalid anyway. I'm just going to stay at my same score. If my opponent lost, I'm just going to stay at this score, which is true, right? Nothing changes in my state here. So this is something I had to put in. But otherwise, I'm going to move to 15, right? That's from my score perspective. And that's all I'm looking at here. That's the best part about this state pattern is I'm only thinking about this, and it makes it easy to test and easier to reason with. Let's go to a hard one in here. If I am at 40, I want to use a switch expression here. If my opponent won, I stay where I'm at. If my opponent lost, the game's already over, so I'll just stay where I'm at. This will allow me to handle state long after the game if someone decided to change something. If the game's already won or lost, I stay at the same state is essentially what that is. But if I win and my opponent is at 40, see how I'm able to focus on that? Then I move to advantage. If I win and I don't know if that one's correct. No, I'm sorry. If my opponent is at advantage, then I stay where I'm at. Otherwise, I'll win the game. But the idea here is I get to focus on just like one part of the state, right? And that's the idea for this. Now, how do I wire all this in? Well, that was where the fun was here. And I'll probably be a little hand wavy in here. But what I decided to do was get a little clever here. And I was inspired by the state monad from Haskell and Scala. Remember, I told you what a monad was using flat maps. But this one over here is like, hey, can I use functions to represent a tennis game? That's where that by function is. So I'm going to give my end user the ability to take two players and they decide who's going to be the winner. And then I'll take that function and I'll do all the immutable hard work here and determine what's going to happen when someone beats who and someone beats another player, things like that. So that way when we run this, And let's take a look at our runner in here. This is what it looks like. So I think with functions, you can, elaborate and imagine different ways that you can write applications like this. State monad, like in Haskell, does this all the time, except I'm not using flat maps here. I'm using like rich methods like next turn. But you kind of get the idea here is that you could say, here's a tennis game between Salvador and Rafael. And right over here, I have tennis game, next turn between Sal and Rafael. And the way you use this is I'm given two players. I'm going to return the one that won that round. Here's another one and another one. And each time I move forward, I have a certain state. So at this point right now, Rafael should be what? 30? Something like that. Rafael should be in the lead though, right? So Rafael should be 30, Sal should be 15, okay? Let's go run that one and let's take a look at the first one here. Well, I think the first print line is at the very beginning. So both love. And then on the second one here is 30, 15. But because I'm using functions now, guess what I could do? I could fork, right? That was like a recurring theme when we talked about functions, is that I could take that state and then do next turn, carry from that one particular state. So in this case, let's say Sal won them all. Well, here's that state. But in a different branch, well, that's what the alternative universe is, but like on a different branch, let's say Rafael won it. So I get to branch off of one state and create different alternate scenarios from this because that's just the way functions work. I think, well, I wrote it, but I think a really nicer, state on there, or nicer state pattern. Cool. Woo. All right, let me finish with this one. How many of you ever dealt with the interpreter pattern before? This one comes close to my heart. The interpreter pattern was this one. It was often called the most useless design pattern. And here's the classic one. The idea for an interpreter pattern is to create a programming language within a programming language. That's the idea for an interpreter, okay? Often used for creating DSLs. So something like this, where I have an expression, this is the classic pattern, and I have a context that I'm bringing in. I could have a constant, so what I'm writing here is a calculator. With the number, here's the constant. Here is multiply. Multiply takes a left expression and a right expression. And what do I do with this? Is interpret it. Now, this is the classic pattern. What's wrong with this? My opinion is that the interpretation is hitched to the model. What if I wanted to interpret things differently? I'm locked in. Have you ever thought about toString? Like toString is a lock-in, right? It's a implementation or an interpretation of what your object should look like as a string. But you're locked in. That once you write that toString, you're kind of locked in and you can't really change it because everyone else is dependent on that toString looking a certain way. But what if you wanted to write it a different way, right? You're kind of locked in there. So in this case here, this interpretation here is kind of locked in. This is a multiply. What if I wanted like a string representation for that? I'm kind of locked in. And so here's subtract, right? The interpretation's locked in with a model. But all in all, it works pretty well. And so therefore, if we call that particular runner, this is the way that it would look. And again, I'm actually just implementing a calculator within Java. So like on line 24, sum of constant of 6 with the subtraction of 3 minus 2, I should be able to interpret something from it. And that's what the interpreter pattern is. But let's take a look at a functional reimagining of this. And here's what the constant looks like. Right? It's just the model, right? The interpretation should have been on the outside, not locked in. If I take a look at multiply, here's multiply. Here's subtract. Well, that was easy. Here's sum. But what we're doing here is we're going to take the evaluation or the interpretation outside, right? Should be done elsewhere. And here's an example of that. Here's evaluate, and here's evaluate string, two different interpretations. So yes, what if I wanted to add and subtract for all of these? Here's where the logic is. In functional programming, we call this actually the interpreter, because the interpretation is outside of the models. And that's what we're looking at here. How do we interpret that? Right? I can construct a expression, but how do I want to interpret it? Do I want to interpret it as this regular evaluate, which is actually do the arithmetic? That's one way to interpret it, right? 4,000. But what if I wanted to interpret it as a string, which is this? What if I didn't want to do the arithmetic and I wanted a two-string representation of the expression? I should be able to just call that one as a different interpretation. Nice, right? Different interpretation, which is what that interpreter pattern should have done all along. Nice. And let me sum up with this one, and where I'm kind of like pushing all of you to think about. This one is type level cats. And right over here is what we call a program. The idea for this is that this is monadic programming. This is using functions. This is writing, like in DDD, this would be similar to writing a service, to where you have verbs and things, the business things that you do. I want to put Wildcats 2 in this. I want to use update, and where I want to update Wildcats and add 12 to it. I want to put tame cats as 5. I want to get the number of Wildcats, and I want to get I want to delete tame cats from here and return the number from it. All these here are actually in type. This is Scala and type level cats. These are just all flat maps. Flat map, flat map, flat map, flat map, map, kind of like what I was mentioning to you. So this one's a compiler, but let me scroll down further here for running it. This fold map here is your interpreter. So you write a program using flat map, flat map, flat map, map. That's really what this is. You call that a program, and then you interpret it here with something called a compiler, which is evaluate everything, and I'll do the work thereafter. Okay. So there's a whole functional road for these design patterns. Same design patterns that we know and love, different take on it, different reimagining of it, using functions. You could reimagine, your own style for a lot of these particular patterns. But think about this. I think there's a different future in Java the more functional we get. One of the things I do like about Java is that I think where Scala had some issues, Scala said, here's everything functional that you ever desired. And you're like, what do I do with this? I don't know what this is crazy. What am I going to do with it? Whereas Java kind of like, here's a little bit to intrigue you. Give that a try. And we're going to add a little bit more. Give that a try. A little bit. Give that a try. And that's why I think, we've, for at least for Java programmers, we've really become excited over time because that has been trickling in. Who knows where Java is going to trickle in, but it may trickle into these kind of patterns as we proceed into the future. Okay, cool. All right. Hopefully your brains aren't burning too much. Hopefully that was exciting, but I'll leave it at that. All right. Thanks, everyone. Oh, yeah. I'll plug the monitor back in. Sorry. Yeah.
To know which design patterns are most popular for developing internal banking applications?
What kind of? No, so you're looking for a framework or?
The because stuff mostly their other programs, internally their Java programs.
Oh, okay.
So just curious if, I mean, design patterns are everywhere, right? So if would there be one that they would want to use in particular that would be for beneficial for their purposes or something like this?
Yeah, and I think there was a missing word there. How'd you say that, Zeit? Oh, popular design patterns for banking. I don't think so, and I don't know if there's any like occupational patterns. They're mostly, to me, like programming design patterns. But maybe there are. Maybe there are things that banking applications have done over and over again, and maybe they're just the design patterns that we were talking about. We found this pattern to be absolutely great for this particular application within banking. I think that's probably the way it would go, but I'm not in the officially in the bank. Yeah, I don't know. There could be, and I think you probably find that more in like banking consortiums, like software design, and there likely would be, hey, we use this particular pattern for our particular need, and then that would just like, hey, that's the one that we're going to use, and that's the one that's gonna help us. Yeah.
Because as you probably know, floating point numbers, right? We lose money if we use them for monetary values due to rounding issues. So you'll often see value objects around them.
Yes. Yeah. So one of the ones would be like one of the things I learned is that wrap money around pennies as integer values or really large integer values, so you don't lose any information just because of floating point. You end up missing fractions of money all the time, like those things like that. Like it's the same pattern, right? It's still the same value object pattern, but just a different application of it for a particular domain. Yeah. And I think that's where the conversation may lead. But again, if you talk to other financial programmers, and you should, like all of you should, get together and find out like what are the things that work, what are the patterns that work for us. Yeah.
Build rapid and you use those objects, you could effectively exploit that for salami slicing.
Yes. But it's worse than that because the numbers don't add up. So if you've ever seen people complain about JavaScript saying, well, if I add 0.1 plus 0.2, it doesn't equal 0.3. Well, yes, that's normal because that's the way floating point numbers work. It's true in every language. But that's a huge problem if someone put 10 cents in and then put 30 cents in, or sorry, 20 cents, they're expecting 30 cents, not 29.
Yeah.
Well, and then it becomes a much, much greater issue when you're talking about thousands, tens of thousands, hundreds of thousands.
Sure.
Yes and no. I mean, the floating point is more of a problem like when you divide, like 1 divided by 3, you get 0.33333 repeating. It turns out that if you use base 3, you wouldn't have that problem. Floating point uses base 2, and it has its own weird division situation where you get repeating numbers. That's what caused the problem in the first place.
Yeah, but you know what? You gave me an entryway as well. There's a whole other set of different patterns, like in web applications, model view controller, and there's that model MVCC1 or whatever. But the other thing that you're probably going to find in financial space is that financial space uses a lot of event-driven architecture, but those are architectural design patterns. So when a deposit is made, for example, that deposit gets turned into a message and goes into a Kafka or a Pulsar or some sort of pub sub. So you need to ensure things like item potency, make sure you're not redoing the deposit multiple times over and over again. You're going to think about exactly once semantics. And so there's a whole other layer of different design patterns there that are definitely going to crop up. Just because you're in the financial space. You don't want multiple deposits. You don't want multiple withdrawals. You want that exact one on there. And because you're using a messaging service, that becomes important as well.
What?
EDA, event-driven architecture. I think most do. I would be surprised if they didn't. That's where you use a messaging system to send deposits, withdrawals, transfers, and everything like that. Those are usually done in messages. But once you start dealing with distributed messaging, there are a whole lot of concerns that you have to think about. The first one was idempotency, and the other one was exactly once semantics. And then afterwards, I could fill you in all that stuff too, so that way you could get a list for that. So if you're likely going to be going down that road as well. So you have the software patterns that I was telling you about today in Java, but then you have architectural design patterns, which is another whole list of patterns that you would want to take a look at for whatever job that you want to endeavor into. Architecture patterns are just as important as software patterns. Yeah, wonderful. Any other questions? All right. Pizza time. I'll be here for any other questions. And thanks, everyone. Yep. Thanks, Mary. Oh, okay. Did you need my computer? Or are you going to hook yours up? All right. There we go. I left it up here. So, oh, you're probably not going to plug in. You're probably just going to use a battery.
Let's see. This one is this one. Let's see. Take a second. Stick. Okay. Everybody can see it, right?
Yep. Oh, the Wheel of Fortune, huh?
Yep. So I got these names, right? We have let's see, Katerina and Daniel, Ruswick, Priyasmita, Lokesh, Asher, Svetlana, Tom, Point, and Robert, Igor, Madhu, and Jayashri, Alexandra, and Eduardo. So, and you too. Oh, did you enter your name yet into this form? Okay, I can put your name and then you can, if you get picked, you have to give me your email address. So what is your name? O-L-I-S-A. Okay, yeah, right. Okay, so now we get all these names, and let me see is the online folks, and maybe if Che can check, make sure they're online folks if they want to be in the JetBrains. Anybody?
So far, no.
No, nobody. Yeah. Okay, that's fine. Yeah. So we're going to do 3 drawings. First 2 are for the JetBrains licenses, and then the third one will be for the No Fluff Just Stuff free ticket to the Chicago conference. So okay, let me also turn on the sound because of sorry. You know what? Let me I'm actually.
Oh, you had the echo.
Yeah, I was echoing, and I was testing my other thing. So let me stop that now. Let me go back to my thing. Okay, and then we can hear because it's got some interesting cheering too if you win. So, all right. So number 1, the first JetBrains license.
Robert, nice.
Yeah, well, Robert's here. Yeah, you have to be here. Is Robert here?
Boo!
Oh,
That's right.
he left. Oh well. All right. Well, yeah. Okay, then. Sorry, Robert. You will not be.
Shit, I won. That's right.
Okay, we'll have increased probability for the ones in here. Let's do it another one. Ah.
Hey.
Oh, Lisa.
Hey.
Okay, great. Yeah. Okay, cool. Now the second JetBrains. Yeah. Yeah.
Somebody want to go to check.
Oh, they want to join now? Okay. Well, it's a little too late. Yeah. Sorry. Yeah. Okay. Sorry about that. Maybe next time. Okay. Eduardo is there. Okay. But I got your email too. But Olisa, I'm going to need your email. Okay. And sorry again to the virtual Java users group person, because you didn't tell me ahead of time, so I can't go back now. So, but the third one, we have one more raffle is for the No Fluff Just Stuff conference ticket. So, okay, here we go. Igor! Igor! Okay. All right. I'll have to connect you then with the No Fluff Just Stuff organization, then they can mail you the information. Yeah, so with that, this meetup is ending, and but we're going to be here for a little bit more too, if you want to hang out and socialize and talk too. So yeah, thank you so much again for coming. Yeah, thank you, thank you.